Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic: global foundries and Dutch chip design company Qualynx have demonstrated a fully Europe internal semiconductor manufacturing flow, from design all the way to finished wafers, without the data ever leaving European borders. This is not a story about raw performance. It's a story about who controls where and how critical chips get made, and why that distinction is becoming one of the most important questions in the industry today. As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Today's analogy: imagine a country that needs to print its own banknotes and passports entirely within its own borders. So sit back and enjoy. Let me put today's news into familiar terms. Imagine a country that needs to print its own banknotes and passports. Both of those documents are incredibly important to that nation. They represent its identity and its sovereignty. So naturally, how they're handled and where they're produced becomes a very serious question. Now, suppose there's a foreign printing factory that charges far less than anything available domestically. Would that country send its banknotes and passports abroad to be printed there? Almost certainly not. And here's the key reason. It's not about whether the print quality would be good enough. It's about the printing plate itself. The design, the template, the blueprint of the banknote. That would have to leave the country too. Once that printing plate is outside your borders, the risks multiply quickly. Someone could quietly run off extra copies. Someone could study the plate closely enough to produce near-perfect counterfeits. That's why the most sensitive documents are always printed domestically, not just to keep the product at home, but to keep the plate, the design, the source of truth, firmly under national control from start to finish. That principle is the foundation of today's story. Semiconductors face the exact same challenge. Chips used in national defense, space systems, power grids, and critical infrastructure can carry designs that are considered state secrets. In the banknote analogy, the printing plate maps directly onto what we call the design data, the detailed blueprints that tell the factory exactly how to build the chip at the atomic level. So what happens if you send that design data to a factory in another country? The data has to travel across borders, and along that route, there are risks. It could be intercepted. It could be accessed by parties you didn't authorize. Even worse, during the manufacturing process itself, someone could quietly insert extra circuitry, what the industry calls a hardware backdoor, without your knowledge. Sending the design abroad is, in terms of risk, almost exactly like handing over your banknote printing plate to a foreign government. Let me summarize the banknote printing stance. The goal isn't to make the most beautiful banknote in the world. The goal is to make sure the plate never leaves your hands, that every step of the printing process happens where you can see it, and that the chain of custody is airtight from the moment the design is finalized to the moment the finished product comes off the press. That's what matters most when the thing you're producing is a matter of national security. And honestly, what global foundries and Qualynx have demonstrated in Europe maps almost exactly onto this banknote printing story. The news isn't that they built the world's most powerful chip. The news is that they've proven a manufacturing route where the design data stays inside Europe. The wafer fabrication happens inside Europe, and the entire chain of custody can be accounted for end to end. That's the real breakthrough. Now, let me walk you through what actually happened and why it matters for the industry. The two companies at the center of this story are Global Foundries and Qualynx. Global Foundries is a contract chip manufacturer headquartered in New York State. It doesn't carry the same name recognition as Intel or TSMC, but it has a strong track record in specialty processes and in manufacturing chips for defense and aerospace applications. Qualynx is a Dutch chip design firm. Together, they announced that they have demonstrated a fully Europe internal manufacturing flow, one in which Qualynx's design data travels to Global Foundries' European fab and is turned into finished wafers entirely within European borders. No design data crosses outside Europe at any point. This is what the industry calls an end-to-end sovereign manufacturing flow. And while it sounds technical, the significance is fundamentally geopolitical. It's about controlling the supply chain from a national security perspective, not just an engineering one.
One important clarification here. The chip Qualynx designed for this demonstration, the QLX3XX series, is a consumer and IoT-grade GNSS receiver chip. In plain terms, it's a chip that picks up positioning signals, of the kind you'd find in wearables, pet trackers, drones, and vehicle tracking systems. The chip itself is not classified. It's not a military secret. That's actually an important nuance to understand before we talk about what this demonstration really proves.
The real significance isn't what was manufactured. It's the fact that the manufacturing route itself works. By proving that a design originating in Europe can be fabricated in Europe without the data leaving European jurisdiction, GlobalFoundries and Qualynx have laid the groundwork for something much larger. In the future, if a European defense contractor needs to manufacture a genuinely sensitive chip, that same route is now available to them. In my experience working in the industry, for defense and national security applications, the ability to trace and control the manufacturing path often matters more than raw performance specs. That's exactly what this demonstration establishes.
GlobalFoundries' involvement in this effort is closely tied to the European Chips Act, a major EU policy initiative aimed at building up semiconductor manufacturing capacity within Europe. The EU has committed substantial funding and policy support to reach that goal. GlobalFoundries already operates a manufacturing facility in Dresden, Germany, which makes it a natural anchor for Europe's sovereign semiconductor ambitions, and one of the most important players in making those ambitions real.
Qualynx, on the other side of this partnership, is a fabless design company based in the Netherlands, spun out of Delft University of Technology. Their chips are built on proprietary digital RF technology and are designed for ultra-low power consumption. What makes their GNSS SoC particularly interesting is that it supports OSNMA, a signal authentication feature of Europe's Galileo satellite system, which gives it a built-in security dimension even for civilian applications. For this project, Qualynx optimized their design specifically for GlobalFoundries process technology, which is what made the fully integrated end-to-end European flow possible in the first place.
A quick note on the process technology involved. GlobalFoundries used its FDX platform, which stands for Fully Depleted Silicon on Insulator, or FDSOI, at the 22nm and 12nm nodes. This is not cutting edge in the sense of the 2nm or 3nm processes you see in the news for smartphones. But for defense and aerospace applications, cutting-edge node size is rarely the priority. What matters in those markets is radiation hardness, how well the chip holds up when exposed to cosmic rays or electromagnetic interference, combined with long-term supply guarantees and a strong reliability track record. FDSOI delivers all of those. Once again, the theme here is not performance, it's trust and reliability.
This model isn't new. It already exists in the United States, and the company running it is GlobalFoundries itself. GlobalFoundries operates facilities in Malta, New York, and Burlington, Vermont that hold U.S. Department of Defense Trusted Foundry accreditation. Chips that require high classification levels for defense programs are manufactured at these certified sites. What Europe is doing now is building its own equivalent of that trusted manufacturing model, and GlobalFoundries, already experienced in playing that role for the US, is the natural partner to help make it happen on the European side as well. It's still unclear how quickly this demonstrated flow will scale into high-volume production, but the direction is unmistakable. European defense budgets are rising sharply, and the demand for manufacturing routes that can be certified as sovereign, fully within European control, is growing with them. Since the conflict in Ukraine began, European governments have accelerated their push for strategic autonomy across many sectors, and semiconductor supply chains are very much part of that conversation. On the industry side, if more European fabless design companies start building close working relationships with fabs like GlobalFoundries or STMicroelectronics, it will thicken the European chip design ecosystem as a whole. Europe has historically had design strength without matching manufacturing capacity.
With dedicated fabs now stepping up to carry that manufacturing role, the two halves of the equation are starting to come together.
What I'm watching closely is how the ability to prove and document the manufacturing route becomes a genuine business differentiator going forward. It won't just be a label that says "Made in Europe." Procurement decisions, especially for critical infrastructure and defense, will increasingly be based on detailed traceability. Where did the design data travel? Which facilities handled it? What certifications do those facilities hold? This kind of manufacturing trustworthiness, made visible and verifiable, is going to become a standard part of how high-stakes chips are specified and sourced. I believe this shift will accelerate, not slow down.
Let me recap what we've covered. Global Foundries and Qualinx have demonstrated a semiconductor manufacturing flow that runs entirely within Europe, from chip design to finished wafers, without design data crossing outside European borders. The chip used in this demonstration is a GNSS-OC aimed at consumer and IoT markets. But the point of the exercise isn't the chip itself. The point is that the route works. The process technology is Global Foundries' FDX platform at 22 nanometers and 12 nanometers, FD-SOI-based, well-suited for radiation hardness and long-term reliability. And Global Foundries has already been operating the same trusted foundry model in the United States for years. What we're seeing now is that model beginning to take shape in Europe.
To wrap up, the core of this news is not about chip performance. It's about the choice of manufacturing route. In critical infrastructure and defense, the trustworthiness of where and how a chip was made carries its own value, independent of what the chip can do. Global Foundries has already been doing exactly this in the United States under the Trusted Foundry program. Today's announcement is the European version of that model coming to life. The US led the way, Europe is following. The question I'll be watching is how this dynamic eventually extends to Japan and other allied nations as well. The instinct to lock down the manufacturing route for sensitive applications is entirely natural, and the demand for it will only grow from here. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.